Hello everyone, welcome back to my YouTube channel. Myself, Akanksha Study from Sri Venkateswara College of Engineering, and I'm studying in ISC department, and my ESN is 1VE22I006. Today we'll like to study about additional list operations, sparse matrix, and double linked list. First, we'll study about single linked list. A single linked list is a linear data structure in which the elements are not stored in a contiguous memory location, and each element is connected only to its next element using a pointer. Each node holds a single value and reference to the next node in the list. The list has head, which is a reference to the first node in the list, and a tail, which is known as last node in the list. And we can see that there are several operations in the list, and we'll study about few operations like traverse, insert, and delete. There are various linked list operations that allows us to perform in different actions on linked list. For example, insertion operation adds a new element to the linked list. Here is a basic linked list operation that we will cover in this article. A. Traversal. Accessing each element of the linked list. Accessing each element in the linked list, single linked list is easier because it has the only one side operations like forward or backward. Insertion adds a new element to the linked list, and deletion removes an existing element from the linked list. First, we'll study about traversal linked list. Display the element and content of a linked list in very simple way. We keep moving the temp node to the next one and display its content. When temp node is null, we know that we have reached the end of a linked list, so we can get out of the value. And here is a syntax for it. It says that struct node into temp, where temp is a pointer variable which points to a side. Print f, and it prints the list elements. While temp is not equal to null, print f. Here it prints the elements stored inside the linked list. And temp is equal to next. And it temp repeats until the temp is null. Inserting element at the beginning. Locate a memory for new node. Store the data. Change next node to the point to the head. Change it to the point recently created node. Struct node into new node, where new node is a pointer variable. New node is equals to mmalloc into struct node, where mmalloc is a memory allocation, where we can allocate a single large memory, and new node is equals to 4. And we use new node to is equals to add, then add is equals to new node, where we create an object. Insert an element at the end. Allocate memory for a new node. Store the data. Traverse to the last node. Change in next of a last node to the recently created node. Struct node into new node. New node is equals to mmalloc into size of a struct node, where mmalloc is used to allocate a memory dynamically, where it allows a single large space of memory. New node is equals to 4, and new node next is equals to null. Struct node into temp, where temp is equals to is a variable that used to allocate a used as a pointer. While temp next is not equals to null, temp is equals to it repeats until the temp is null. Insert at the middle. Allocate a memory and store data for a new node. Traverse to the node just before the required position of a new node. Change the pointer to the new node, and a node is made between. Deletion from a linked list. Pointer head to the second node, head is equals to next. Deleting a linked list from the front. Traverse the second linked list to the element. Change its pointer to the null. Struct node temp is equal to head, where temp acts as a pointer variable, while temp next is not equal to null, temp is equal to temp next. And it repeats temp till the temp is null. Deleting an element from the middle. Traverse to the element before the element to be deleted. Change next position pointers to exclude the node from the chain. And we learn about a topic called sparse matrix. A matrix is a two-dimensional data object made of m rows and n columns, therefore having total of m into n values. If most of the elements of the matrix have zero values, then it is called sparse matrix. And you may ask that why to use sparse matrix instead of simple matrix. There are ways to many reasons to use sparse matrix. There and I'll explain any two. First one, storage and computation time. In storage, the lesser the non-zero elements than zeros, thus the lesser memory can be used to store only those elements. Computation time. Computation time can be saved logically designing a data structure that only travels only in the places of non-zero elements. Here is an example for the sparse matrix. Example, here it contains more zero elements than non-zero elements. Representation of a sparse matrix. We can represent in many ways. Representation of a sparse matrix in 2D array, which leads to a lot of memory wastage as zeros in the matrix are no use to most of the cases. So instead of storing the zeros with non-zero elements, we only store non-zero elements. Thus means that non-zero elements with the use of triples like row, column, and value. Sparse matrix, sparse matrix can be done in many ways, but we use today is array representation. 2D array is used to represent a sparse matrix in which these rows named as row, index of row, column, index of column value use both the index of row and column, where non-zero element is stored in the row and in column where non-zero element is located. Value uses both non-zero element at the index. Double linked list. Double linked list is also known as doubly linked list. Doubly linked list is a special type of linked list in which each node contains a pointer to the previous node as well as the node of the linked list. And we can see in the example that A uses previous pointer and next pointer to store the address of the B value. Advantages of double linked list over a singly linked list. A double linked list can be traversed in both forward and backward direction. The deletion operation in the double linked list is more efficient if a pointer node to be deleted is given. It means that if the pointer where the node to be deleted is given, it can efficiently do the operations. We can quickly insert a new node before a given node. In a single linked list, to delete a node, a pointer to the previous node is needed. To get this previous node, sometimes the list is stored. In double linked list, we can get a previous node using the pointer. In single linked list, to delete a node, we have to traverse whole linked list, but it is in the in double linked list. It is not in that way that we can delete or add in front or back easily than the single linked list. Disadvantage of doubly linked list over a single linked list. Every node of a double linked list requires an extra space for a pointer variable. It is possible to implement double linked list using a single pointer. To represent a previous pointer and previous node, we have to allocate so much memory that it can sometimes even it can lead to the storage shortage of storages. So in order to reduce the storage shortage of storages, we use single linked list. All the operations requires extra pointer in the pointer need to be maintained. And it says that it requires an extra pointer to easily access the previous pointer nodes or previous nodes. So to maintain that, we need extra memory, which can be trouble causing in the future. Applications of doubly linked list. It is used by web browser for backward and forward navigation of web pages. As you can see that in the web pages, you can easily move forward or backward. Those are built by double linked list. As it is so much useful because if you want to go back to the previous page which you are referring, if you can easily go back. Or you can move forward if you doesn't need the previous web page. LRU, which is also known as least recently used. And it is known as you can once you open a browser, you can see that if you use the recent used page, it pops up that this is the page you have recently used. And next one is most recently used. It is a cache which is built by double linked list. If you open the any you like which is the most accessed thing in your mobile phone, it can be accessed using these caches or constructed using double linked list. And it is used in various operations to maintain and undo and redo functions. If you have deleted any details in your system or computer, it can be easily undo and accessed if you want to redo. And these are the functions which are built by doubly linked list. In operating systems, a doubly linked list is maintained by a thread scheduler. A threads to keep the track of the processes that are being executed at that time. And double linked list has way more advantages and applications than single linked list. Thank you.